simplifies to 1, and you have 2x to the 4th, right? And then add your y exponents, y to the 5th, over x, y to the 4th. Okay? Then you could use that division law where you're subtracting exponents. So that would equal 2x to the 4th minus 1, right? And y to the 5th minus 4. Okay, so that's going to give you 2x to the 3rd y. Does that make sense? Okay, so with something like this, complicated like this, first look for any x, anything raised to the 0 power. Then I would do the multiplication rule on top first. Okay, so add your exponents of your like bases on top. Make sure you keep that coefficient. And then if you've got exponents on, or bases with common bases in the top and bottom of your fraction, subtract your exponents from the bases in the denominator and the numerator. Okay. Any others? Those? Just warn you guys down here.
So yeah, our math teachers.
Can we go over that? Sure. Okay, so scientific notation. You can always use your calculators for these. You've got to ensure that your answer you put back in scientific notation. So for 17.
Shoutouts. So weird. Let's give shoutouts to Donna. I love you, Donna. Hi, Donna.
All right. So like that, you can also just reorder the multiplication here. That's equal to 7.1 times 2.5, right? And 10 to the negative 4th times 10 to the negative 2. So you can start off by first figuring out what that is. Which one did? Pardon me?
That's what I did when you gave me a phone.
I don't know, maybe did I do something wrong? So this should be 17.75, and you multiply that, and this would be, you add your exponents times 10 to the, 10 to the negative 6. Then you've got to move your decimal place back 1, right? Because when you have 17.5, that doesn't follow the rule for scientific notation where this number has to be between 1 and 10. So you've got to move your decimal point. And when you move your decimal point one place in this direction, you've got to add 1 here. So that's going to be times 10 to the negative 5. Right? Does that make sense? So if they're negative, then you just have to be careful with, when you're adding or subtracting exponents there. So you need to do 18 here, you get the hang of that. Anybody else? All right. And then when you just have numbers like 19, you have 125,000, and you're asked to write that in scientific notation. You just start off, you just count, put a decimal where it would be there, and then you count how many places you're moving the decimal so that you're producing a number between 1 and 10. So 1, 2, 3, 4, 5. When you rewrite that as 1.25, and okay? And if you're starting off with a decimal, like you count how many places you're moving that decimal to the right, and you're moving a negative exponent. So you're moving that 3 decimal places to the right to get a number between 1 and 10. So you're going to multiply that times 10 raised to that exponent, a negative one, in the negative direction. Right? So remember that 10 to the negative 3 is equal to 1 over 10 to the 3rd. Right? Which is equal to 1,000. So when you're multiplying a number times 1,000, it's the same as moving the decimal place 3 places to the left.
This wasn't.
All right. Okay, so you guys did really well on this. If you of you didn't do great on this, make sure you know how to do this stuff. Because these quizzes, as I said, are going to be cumulative. I'm going to do the recording format, it's no longer great, I'll probably do multiple choice. But if you do well on successive quizzes, I will count this one less because it's cumulative. And what matters is that you learn this stuff, okay? Not that you have a great day every day you take a quiz, all right? And I'll also drop the lowest quiz grade. Okay, so don't lose heart if you didn't do well on this, but you need to understand how to do these. So my advice would be to go through it with the answers, make sure you can do them. If you can't, I'm in here every single lunchtime except for Fridays when I have hall duty. I'm out there. So you're welcome to come any lunch for extra help. Okay, or arrange to stay after if that works. Okay. Next on the list here. Okay, I was going to put the homework solutions up so you can look over those. And then we were going to go over function notation.
I'm just kidding. I don't know where it is. Oh. Yeah. And I'm watching this like cool stuff. Oh no! I want to draw on my wrist, but no. Whatever. Wait, I want to draw something. Me? Yeah. Unless we get in trouble, and I'm scared that my mom comes home at 7.
All right, so the homework exercises, I think there were 1 through 6. Is that correct? So those are the easy answers here. There's a lot of words here, but just focus on what the graphs look like here. And I'll put the other ones up in a second. So here's 1A and 1B. All right. Those were those graphing those functions without numbers, just qualitatively. 1C, 2A, and B. You guys see those?
Yeah.
Sorry. No? Okay. Oh, God. I'm sorry.
My D graph.
I
Take
tried
the left side of my D graph on another side of that.
Uh,
On the D graph.
uh-huh.
Like you're like a bit there.
Okay.
and stretch my skin.
Yeah, that's fine.
I put it.
These are very qualitative, so if yours aren't exactly like the ones in the book, this is 2C, 2D. Okay. So you were doing continuous functions, and then number 4 had discrete ones, which were the same, similar shapes, but you're using dots instead of a continuous curve. And then number 3, you were supposed to express some of those as inequalities. Just a little challenging.
It's like this is high. Wait, don't do that. Stop.
And then for 5, I think there were some variable answers for that. 5A, you can't read that. So the reading on the scale depends on the weight of the dog. So the dog's weight is the independent variable, and the reading on the scale is the dependent variable. Dog's weight was independent variable. Reading on the scale was dependent variable. The amount of time you spend in the plane depends on the distance you fly. So the distance between cities is the independent variable, and the amount of time in the plane is the dependent. Number C, wax sticks to the candle wick each time you drip it. So the number of drips is the independent variable, and the diameter of the candle is the dependent variable. And I decided to go up to 6. So there's answers to 6. And if you have trouble reading these, I can ask you to